We're going to look at rearranging equations, but from a very maths-phobic point of view. So for people who don't really like maths, you've got to be able to rearrange equations. Don't be tempted into trying to learn formula squares. They're great for simple equations, but when you get that or that, well, that one can be used in a formula square, but it's difficult and it doesn't help that much. And this one just can't at all. So if you don't learn a bit of basic algebra when the equations are nice and simple like this one, you're going to struggle when things get harder later on. Right, so first thing is I want you to distinguish between the idea of being on top and underneath. When you've got a fraction, that's dead easy to see. But what is S? Is it on top or is it underneath? Well, if it's underneath, it's really obvious. There'd be a fraction line, there'd be something written up here, and that would be on the bottom of it. So if it's not under a fraction line, then it's on top. There could be something here. We generally would write divide by 1, but we don't write that because that's really stupid, so we just leave it like that. So that's the first thing. The other thing you'll notice is that I've just written this a little bit strangely. You might normally prefer to sort of write it like that. I've just put this up there. Gives me space to move things around in a second. And what I'm also going to do, which you wouldn't normally do, is put a little line there as well. So what I recommend you do when you're practicing rearranging equations is tear out a piece of paper that's got S, D, and T written on it, and then just draw just the two lines, then the equal sign on a piece of paper underneath. And then you can physically rearrange the equation. So I'm going to do that with these letters in a second. So what are the rules? Well, they're sort of three-ish. Two are just about what you're after. So if you're after a letter, so you're after S or D or T, you must make sure that it's two things. One, it must be on top. So you must move things so that they are on top if you want the equation for them. Two, they must be on their own. I just mean on that side of the equal sign. So for example, D is on top. T is not. S is on top. But S is on its own. D and T are not on their own because they're together. So if we are rearranging and we want an equation for speed, we've got it. S, speed, is on its own. It's on top. Everything else is on the other side of the equation. That's what we need. Okay? So in order to achieve those things, we've got to follow the third rule, which is that the equal sign is magic. So when you cross the equal sign, you do the opposite. So what that means is if you've got something that's multiplied, you divide by it when it crosses the equal sign. If it's added, you take it away. If it's taken away, you add it. If it's squared, you square root it. Okay, whatever it's doing, you take it across the equal sign. The thing you need to get rid of, the thing you need to move, and you get it to do the opposite. Let's look at a few examples so you can see what I'm talking about. Right. So in this instance, we've got speed, distance, and time. So let's just say I want the equation for distance first. So I want the D. Now, two rules, on top and on its own, first of all. It is already on top, so rule one sorted. We don't need to move the D at all. This is really important. What a lot of people do is they make this mistake. They go, I want D, so they start with D equals, and they go, so I've got D, and then must have, and then they do something strange, and it doesn't work. Okay? Don't do that. Leave, if it's on top, which it is, leave it alone. It is going to end up on the wrong side of the equation, but I'm going to show you in a second why that's not a problem. So it's on top, it's not on its own. Why is it not on its own? Because this is here. So what we actually need to do is move the T. We need to get rid of it. We need to clear up around the distance, the D, okay? We need to move everything else. That's how I think of it. We're clearing up. We're shifting this T to the other side. So where do we put it? Well, I can't just do this. And if you're ever unsure about whether you're allowed to do that or not, just imagine doing it with some real numbers. So let's go with 4 equals 8 divided by 2. That's perfectly true. If I picked up that 2 and just shoved it underneath over there, well, 4 divided by 2 is 2. That doesn't equal 8, so you're not allowed to do that. It doesn't work. You can always check rearrangements with really simple numbers like 2, 4, and 8. Just make sure it works to start with as a sum, and then do the same rearrangement. And if your numbers don't work, your rearrangement is wrong. We need the third rule, do the opposite. So pick up t. Okay, so currently this line means divide by. What's the opposite of dividing by? Times, multiply. So what I can do is I can pick this and I want to do across the equal sign, but I want it to be times. It would be divided if it was down there. I need the opposite, which is times. So I stick it up there. We don't have to put the times symbol in, but there's nothing wrong with doing it. One little thing just to remember, and I know there's lots of little things, but you get used to these the more you practice them, is there's no difference between that and that. They both mean exactly the same thing. In the same way that 2 times 4 equals 8, 4 times 2 equals 8. When you're multiplying, there's no difference. Dividing is different. 8 divided by 4 is not the same as 4 divided by 8. All right, but when you're multiplying, it doesn't matter which way around you do them. Okay. So this gives us an equation for distance, but lots of people don't like this because now they've got an equation that looks backwards and it looks all wrong. Well, remember, if 2 times 4 equals 8, 8 equals 2 times 4. That's not a rearrangement. I'm literally just writing this the other way round. We're not rearranging anything. Nothing is crossing the equal sign here. We're just writing them the other way round. So distance equals speed times time, or distance equals time times speed. Both the same thing. Doesn't matter which way you've ended up. Okay. Right, let's go back to where we started. Let's imagine now that I don't want an equation for distance. Imagine I want the equation for time. Little bit tricky, but not much. Remember the two rules. It's got to be on top. It's got to be on its own. So first rule, we've not met. It's not on top. So the first job is to move time so that it is on top. We're not allowed to just do that. That doesn't work. Again, if you're not sure why, 4 equals 8 divided by 2. So can I just pick that 2 up and pop it on top? No, because that's 16. It doesn't equal 4, so that doesn't work. We can do those little checks very easily. So if I want to move something, the only thing I can do is move it across the equal sign, and I have to use rule 3, which is do the opposite. Basically, this is what we've just done. It was divide, it becomes times. We bang it up there. We've got speed times time. But I want the equation for time, so I need it to be on top. Tick, got that. I need it to be on its own. No, haven't got that. Why is it not on its own? Because this is there. So what I need to do now is move the speed. I can't move time because I've got it so that it's on its own and on top. I need to move the speed out of the way. So nice and easy. We just pick up the speed. Remember that that's speed times time. So if we want to do the opposite to get rid of this, move it across the equal sign, it has to become the opposite. Divide by. Now, what some people do at this point is they go, right, so I'd pop, it's divide by, so it's, but no, it's divided by the speed. That d can't just move from there to there. The only way things can move is across the equal sign. So we can't just shift things around. This is why having them on a piece of paper and physically rearranging them, rather than writing it out on paper, works a little bit better until you get the idea in your head. Okay, so now we've got the equation for time, and it is even the right way around, which is nice. Time is distance divided by speed. Okay, so tear out some bits of paper and practice that yourself with that equation and make sure that you can rearrange it. So remember that we've got speed is distance over time. We've got distance is speed times time. We've got time equals distance over speed. So check that you can rearrange that to those yourself. And I'd actually pause the video at this point and make sure that you can, without looking at those answers, check that you can rearrange it and then check them against the answers. Don't move on until you're happy that you can. Okay, let's look at another equation. This is exactly the same. It's just we're starting with something with no divide symbol. So I want you to do the same thing. Tear out 3 pieces of paper, write FMA on them, and on the paper underneath, put an equal sign and 2 lines representing the fractions. And let's look at the rearrangements. I want acceleration, I want A. So remember, is it on top? Is it on its own? And if you need to move anything, move it across the equal sign and do the opposite. So is it on top? Yes, it is. If we imagine a line there, it's on top of that line. It's not on the bottom of a fraction. There's a kind of invisible multiplication sign there. It's on top. Is it on its own? No. So what do? Do we move the a? Well, that would be kind of stupid if you think about it. Because if I move the a, the only place I can move it to is across the equal sign, which means it becomes divide, and it's still not on its own. So why would I do that? Leave it where it is. To get a on its own, we've got to shift everything else out of the way. Pick up the m, move it across the equal sign. Okay, so once again, I've got this backwards, but I can just write this however I want. So a equals f over m. Notice I've not changed anything about either side. I'm just flipping them round. This isn't a rearrangement. Nothing's moved across the equal sign. There's no opposites happening there. We're just writing it the other way around. If 8 divided by 4 equals 2, 4 divided by... if 8 divided by 4 equals 2, then 2 also equals 8 divided by 4. You're just flipping them around. We're not changing anything. It would help if I said it right. Okay, let's put it back the way it was. What if I want an equation for m instead? Well, is m on top? Yes, it is. Is it on its own? No, it's not. What's stopping it from being on its own? This. So that's the thing we have to shift. Pick it up, move it. It was m times a, so it becomes divided by a, leaving the m on its own. So mass equals f over a. So again, make sure that you can take the equation f equals ma and rearrange it into any form. Now, if you can do that, you can take literally any equation that's got 3 things in it, and you can now rearrange them. So there are a ton of equations out there that you may or may not have met. All sorts of things. Loads. There's loads. I can't even think. F equals ma. You've got speed equals distance over time. You've got momentum equals mass times velocity. There's loads. There's loads. You can now rearrange all of those equations, even if you don't know what they are. So try it. Have a little go now. Let's just go P equals IV. Don't even know what P, IV, and R. Doesn't matter. If I wanted I, I'll leave it where it is because it's on top. I have to move the V. So I pick up the V and I divide by it. I equals P divided by V. If you do want to know, it's current equals power divided by voltage. But we don't need to know what it is to be able to rearrange it. No formula triangles needed, just basic understanding of algebra. Right, that's a good place to stop and go and make sure that you're happy with those 2 equations. But I am going to go on a little bit and just show you some of the more complicated versions, but we can still use the same rules. There's still a couple of equations you're going to come across at GCSE. So for this one, this is gravitational potential energy. So chances are you'll write it something like, ignore the E there, but GPE equals mg delta H. But you can sometimes write it as, and you should really, write it as E equals mgh. And sometimes people put a little subscript P or something there for potential energy. It really depends. It doesn't matter as long as you know what it is. So I'm going to get that out of the way completely. I'm going to use the GPE version because I imagine that's probably what you'll do. Right, we're not going to change anything about this. There's a couple of things to be aware of. GPE is energy. It's one thing, so we don't do anything we don't split this up. We just treat it like one letter. And we do what we did previously. So we're going to just have the equal sign in the middle, 2 lines, and then tear out a piece of paper, write GPE on one, M on one, G on one, and then this delta H just means change in height. You always keep that together. This triangle here is not a separate thing. It's not a quantity in its own right, all right? It just means changing, so it always stays stuck to the H. That's all one lump. You pick it up and move it as one lump together. Right, so this is an equation for potential energy, or GPE. Let's say that we want an equation for M. We apply exactly the same rules. We want the equation for M. Is it on top? Yes. Don't touch it. Don't move it. Leave it where it is. Is it on its own? No. We've got these 2 things here. Okay, so now we've got to get rid of two things, but it's the same as before. There's a hidden times between these. So if I pick them up and move them, we do the opposite. They become divide. Now there's just one little thing that sometimes people do here, and it's this. They go, right, so that's pick the G up, and that becomes divide, so I put that underneath. And I'll pick the H up because that was also times, so that needs to become divide. So I divide by that as well, and they do something like this. That's not a fraction. That's a multi-story car park. All right, two things you could do. If you want to do the two things separately, when you pick up the H, you go, well, that's divide by. That's fine. That just means it goes on the bottom down here. Leave a little bit of space for it, and bang, there it goes. But in actual fact, you could save yourself a little bit more time when you become confident with these and go, well, this is M times G times change in height, delta H. But this is just M times this thing I don't need. And M is multiplied by this thing I don't need. So just pick the whole lot up, move it all together. Boom, easy. So this is energy divided by gravity times change in height. So even though we're dividing by them, because they're both on the bottom, remember, when you're putting this into a calculator, that still means they are times together. It's energy divided by gravity times height. And the beautiful thing about this is now you've done that, you can actually rearrange this to any of the other versions. So let's just pop that back to where we started. Let's say that I'm going to go with G. So G is awkward because it's in the middle, so it can be a bit confusing. Let's say I want the equation for G. So is it on top? Yes. Is it on its own? No. I have to move this and this. All right, well, from what we've just seen, we now know that's dead easy. We can just pick up the M, and that becomes divide by, and we can pick up the change in height, and that becomes divide by, and bang, we've got it. We could do them separately, or we could do them together. The end result's exactly the same. Remember, 2 times 3 times 4 is 24. 3 times 2 times 4 is also 24. 4 times 2 times 3 is 24. Oh, there's tons of permutations as well. There's another one. But it's basically, it doesn't matter what order these things are in. If you're multiplying them together, you can have them in any order. Right? This isn't, again, rearranging. This is just slightly rewriting things. So I could have it like that if I wanted to. In which case, now those two bits are together, and I can think, if this makes it easier for you, of picking those up in one go and shifting them both down. But it hasn't changed it. We've got exactly the same answer. The equation for G is still this. Gravitational potential energy divided by mass times change in height. So if we wanted to get delta H just for completeness, try to scribble all over everything, pop that back up. If we wanted delta H, we just pick up these two things. And we shove them down there. And the equation for change in height is gravitational potential energy divided by gravity times mass. Okay, so again, this works without a formula triangle, just applying the same rules. You just got to take a little bit more care with it. Okay, so I'm going to then move on to a slightly different type of equation, which has another problem in it, but still an energy equation. So this one's kinetic energy. Right, there's a couple of things going on here that cause confusion, but you still apply exactly the same rules to it. This is the equation for kinetic energy. Let's say we want the equation for, let's go with mass first. Right, is mass on its own? Well, let's draw the little lines in for reference. I'm just going to move that down so it's level with the lines. M is clearly not underneath, so M is on top. So again, don't touch it, leave it where it is. What do we need to move? I need to move this and that. Right, now there's two ways of thinking about this, and it doesn't matter which you use as long as you use it correctly and you're happy with it. The half. You might have this as 0.5. Some equations, they write this as 0.5. That's perfectly fine. It doesn't make any difference. This is still a number. You can still pick this up and move it just like you can everything else. And it's still there with M. And I need to get rid of it because I'm after M. So I can pick this up, shift it underneath. Simple as that. It's just divided by a half now. Now that creates a few issues, but it's still correct. Not to worry. I've also got v squared. Now, people see the v squared thing and they think, oh, I've got to do the opposite. It's v squared. And they fixate on the squared because it's weird and different. Remember, this is just a thing. All right? It doesn't matter what it is. I just don't need it. It really doesn't matter what's in that box, in that thing. I just pick up the half and I pick up the v squared and I just move the v squared. It was m times v squared. So I shift it across the equals and now it becomes minus. It becomes divide by, so it goes underneath, leaving the m on its own. So m, if we just write this the other way around, is kinetic energy divided by a half v squared. Right, that's one way of dealing with this. There is a slightly different way, and it still sort of uses the do the opposite thing. It's just a case of how you visualize that idea of something being its opposite. So let's just put everything back for a second. There we go. Okay, so let's say I want the m, but this time I'm going to think about the half first. And I'm going to say, well, I want to take this across the other side. I'm going to think about doing the opposite. What's the opposite of halving something? Oh, doubling it. The opposite of timesing by a half is multiplying by 2. So another way to do this is to say you could, I'm just going to pop that down the bottom so it's totally out of the way. We could put that as a 2 there. Instead of being a half, it's a 2. And then the v squared is exactly the same thing. Divide by it. So the equation in this case for m is 2 times the kinetic energy divided by the velocity squared. So we had m equals ke over a half v squared, or we had 2 ke over v squared. And if you doubt yourself, or you doubt me, put these in a calculator, and you'll see there's no difference at all. Just put in a value like 10 for the kinetic energy and 2 for the velocity, and then do it 2 times, and then divide by a half, and you'll find there's no difference. They both give the same answer. So it doesn't matter which of those you like, either of them work, either of them are fine. And equally, if you have this equation as, let's just get rid of all that. So if you had this equation, instead of using the half as 0.5, let's just get rid of the half completely for a second and put 0.5 in, you can do exactly the same thing. You could get rid of that by multiplying by 2 over here, or you could get rid of that and bring it down to the bottom and divide by it. Again, you're still applying that cross the equals sign, do the opposite. Right, that's dealing with the half. What about if we wanted to get the v? So let's imagine that I want the equation now for v. So is it on top? Yes. Is it on its own? No. I've got a half, I've got an m, I've also got a squared. That makes it so that v is not on its own. But let's just deal with the first bit first. We can have a closer look at that. So take the half and the m. It's a half m times v squared. So when it goes across the equal sign to get rid of it, it becomes divide by, and it goes down there. What I'm left with is v squared. Okay, so we could do the same idea. This do the opposite. Cross the equal sign, do the opposite still works. What is it about this picture that I don't like? I want an equation for v equals, or something equals v. But I've got an alien attached to it, and I don't want that alien. I just want v. So what I've got to do is move the thing that I don't want. That's the squared. So I've got to pick this up, and I've got to move it. But this isn't times by 2. I can't just put this on the bottom and make it divide. That's not what the 2 is. The 2 is squared. What is the opposite of squaring? When I come over this side, I'm going to pop that down there so it's totally out of the way. The opposite of squaring is square rooting. So that squared sign becomes a square root when it goes across. And you square root everything that's there. Now I've got an equation for velocity. Square root of kinetic energy divided by a half, or 0.5 m. Or it could be 2 times the kinetic energy over m. Again, it makes no difference at all. They are some of the more complicated equations that you'll have to deal with. There is just one more which you may come across. I'm just going to give you one example. There's a few of these. And again, it doesn't matter what any of the letters mean. Remember, we don't really care about that anymore. This is start and end velocity, acceleration, and time. But we can still use the same kind of rules for this. So I'm just going to imagine putting in that line underneath. But I'm going to give myself a little bit more space. Like that. So you can still do the thing where you tear out the pieces of paper, put an equal sign in, put 2 lines. It's just you've got to be a smidge more careful about how you rearrange these things. So let's say that I want the U this time. All right, the U's there. Is it on top? Yes, leave it alone. Is it on its own? No, that's there. Think of this thing as a box with some stuff in it. We don't care about what's in it. We just pick up the whole box and we move it. Now we've got very used to sticking things on the underneath on the other side, so we have to remember that rule, do the opposite. This isn't times AT, this is plus AT. How do I get rid of plus AT? I do the opposite, I take away AT. So we pick up the AT and we do take away AT on that side. So that's nice and easy. All right, let's go for something a little trickier. Imagine that I want A. Okay, so this is where it does take a little bit of practice and it's easy to make a few mistakes until you get used to it. But is A on top? Yes. Is it on its own? No. There's this and there's also that. All right, I really view this as tidying up. These things are all boxes and this is my garage or my loft and that there is a box with some stuff in it and that there's another box that's next to it. I want this thing here. But before I can kind of open this box to get into the thing that I'm looking for, I've got to tidy up everything else around it. So what's the first thing I'm going to do? I actually need to get rid of this first. It's not a very mathematical way of thinking about it, but it does give a strange logic that's sometimes quite helpful. So how do I get rid of something where the two things are added together? I need to take away the one I want to get rid of. Well, I want to get rid of U, so I take it away. Take it across the equal sign where it becomes take away U. Now I've got just a box with some stuff in it. Nothing else. There's nothing there anymore. I've moved it. So I can open the box and look at what's inside. And what I've got is A times T. If I want something that's in there, I'm going to have to divide by the thing I need to get rid of. I want the A. I've got to get rid of the T. So I pick up the T. Oh, try that again. I pick up the T and I divide by it. So A equals V minus U, but all of that gets divided by the T. You could do the same thing to get T if you wanted. Let's just put everything back. Beautiful. So if I wanted the T instead, although I advise you to just pause the video for a second, have a go at getting the T yourself. If I wanted the T, again, I tidy up, I move the U first. That becomes V minus U equals the AT. Then I can open that box. I want T, so I've got to get rid of the A because T is on top, so don't touch it. It's times, so the thing I want to get rid of, I divide by. So I pick up the A and I stick it on the other side, but now it's divide by. So time is V minus U over A. So you might not come across those equations straight away, but they do come up. There are some more complicated than that, but I think that's probably enough for now.